Hey everyone, Fred here, AF Math and Engineering. How's it going? So we're making a video for you today on rational functions, okay? So this is, we're just gonna make a few small videos here, nice and short, nice and quick, and it's gonna be from some tests actually we got a hold of from different high schools, okay? And so you know that this stuff is coming straight from tests that are testing you and evaluating you, and those are the tests that are gonna send you to university. Okay, so with this kind of content here, okay, you know, I wrote grade 11 at the top here. Some of you might be doing this in grade 12, some of you might be doing this in grade 10 or even 9, depending on what your curriculum is. The point is that, you know, at this level in your education and when you're going into engineering or any math-based program at all, it's really important to get this kind of stuff down, okay? Because then, you know, if you're okay with this, and you have the basics down, when you go into calculus at university, it's going to be a breeze for you, okay? Because you're going to have those study habits down. So this is just, you know, practice. So yeah, we're going to make a few videos, and we're just going to do two really quick questions here. And the way we're going to do it, okay, is I'm going to read the question, and then I'll give you a few seconds to pause the video. And I highly suggest you work it out and try and select the letter that's correct, okay? And then after we'll go through the solution for you. So let's get started with the first question. What is the equation of the horizontal asymptote of f of x equals negative 1 over 2x plus 10? Okay, so pause the video here. Give you 5 seconds to do that. Okay, so if you paused and you solved it at this point, good. If you don't know how to do it, that's fine. I'll explain it. Okay, so how do we do horizontal asymptotes? Okay, I'll put a link in this video actually on our horizontal asymptote video. But in order to find the horizontal asymptote of a function, we're going to need to take the limit as x approaches infinity. Okay, so we have f of x equals negative 1 over 2x plus 10. So we're going to take the infinite limit of that. Okay, so we're going to say the limit as x approaches infinity, okay, of negative 1 over 2x plus 10, okay? So if we remember how to do limits at infinity, what we're going to do is we're going to divide each part of this function by the highest power of x, okay? And when we do that, you can see that, okay, we are going to divide each part of the function by the highest power of x, and in this case, it's just x, so x to the power of 1. So we have 1 over x over 2x over x plus 10 over x. Okay, and we're just going to come up here now, and we're going to now apply, sorry, that's a little bit messy there. We're going to apply the limit now. Okay, so we're going to apply the limit as x approaches infinity to this function. And in doing so, okay, I'll just write it out the long way, just so we have a little bit of a refresher here. Okay, so x's are going to cancel there. And then we have 10 over infinity. Okay, and well, what is 1 over infinity? Okay, that's something that you really should know. You should know what 1 over infinity is. You should know what 1 over 0 is. Okay, you should know what 0 over any number is, you know. Later in calculus, you'll like, what is 0 over infinity? That's also a special one. But be very strong with these kind of things, okay? Don't make a mistake here. So 1 over infinity is always 0, okay? So we end up with negative 0 over 1 plus 0, okay? And then that is just 0. So a little bit of a trick here, they threw a negative in here, you know, and that might confuse some people, and they did that to confuse us. But at the end of the day, the negative didn't really matter because the answer was 0, okay? So I hope you understood that. Let's move on to the second one. Which of the following has a horizontal asymptote? Okay, so take a look at the question, read it, look at the possible answers here, pause the video, and try and solve it on your own. Okay, so hopefully you attempted this on your own, you paused it. Let's go ahead and get started. So once again, a very similar question to the first one. I chose that for this reason. So we have all rational functions here, okay? And in each one of them, okay, they're very similar to this question here, okay? So there's a single power of x on the denominator, and there's no x on the top, okay? So if we, for example, let's just take the infinite limit of a, right? So horizontal asymptote, right off the bat, we're going to take the infinite limit, right? So we are going to say, just for a, okay, the limit as x approaches infinity of 1 over 3 minus x, and it's exactly the same thing as this. Okay, we're going to say that limit as x approaches infinity of 1 over x. Okay, dividing each term by the highest power of x, 3 over x minus x over x. That's going to give us 0 over 0 minus 1, right? And as we know, 0 divided by a number is just 0. Perfect. So that means that at y equals 0, okay, and that's y, right? We have an infinite limit. So don't be confused if you get, 0. That doesn't mean that the asymptote doesn't exist. Okay, that just means that at y equals 0, there's a horizontal asymptote of the function. Okay, so if the limit didn't exist, you would get a number, or you would get infinity as your answer. Okay, but when you get a number, a real number, as your answer, that means that the limit exists. Okay, and as you can see, if we just take the limit of all of these, okay, I'm not going to do it, but it's exactly the same thing. Okay, like if you divide, this is just a single power of x, and there's a number on the top. So as you can see in B and in C, do it on your own just to verify, but if you take the infinite limit, you'll get 0 each time, because you're going to just be dividing 0 by a number, okay? So the answer for this one is D. Okay, and sorry, the answer for number 1 was A. Perfect. Okay, so I hope that helped. I hope that made sense. That was just a quick video for you. Do a few more of these and really cement our knowledge in this part of the course. Thanks for watching.